Well, the title explains the aim of this brief video: discovery versus development. But I will use the origami blind spot to explain why connections stay hidden for centuries. For 500 years, origami was just paper folding, an elegant meditation on precision and patience. It was art. But then, around 1980, something extraordinary happened. Engineers suddenly saw origami differently, not as folded paper, but as mathematics made visible, as structural principles waiting to be discovered, as solutions to problems that had not yet been formulated. Today, origami principles are at the heart of engineering. They create medical stents that expand inside blood vessels. They design adaptive building facades that respond to sunlight and temperature, maybe. The ancient art became modern engineering. The origami paper crane made way for a solar panel that unfolds in space. But here is the deeper question. Why did it take 5 centuries? I want to offer an explanation based on ideas that I developed over 20 years ago and which appear in chapter 6 of the Nexus. The difference between complicated systems and complex systems, and the thinking that goes with them. The pictures capture the concept. On the left, a clock, an integrated circuit are complex. They have been put together with a blueprint. A school of fish, the human brain, any brain, are complex. Complicated systems can be understood through their parts. Complex systems cannot. Complex systems exhibit emergence, behavior that is more than the sum of the parts. The complicated, complex ideas map into Karl Popper's clock thinking and cloud thinking. Clock thinking is for complicated systems. Cloud thinking is for complex ones. Clock thinking is analytical thinking, clean thinking. And clean thinking likes clean boundaries, not fuzzy boundaries. Art here, science there, engineering somewhere else. Useful divisions, but they can blind us as to why may exist at the intersections. Origami engineering emerged only when someone saw the beauty of being at the boundary. Consider another example. In 1920, a Latvian artist named Karlis Johanssons created sculptures that held themselves in equilibrium through the interplay of forces. It was beautiful, radical. Sculpture was supposed to fill space. By the way, this was before Julio González, the founder of modern iron sculpture. What Johanssons had discovered was tensegrity, but did not have a name for it yet. The leap from historical tensegrity to modern applications was swift. Once the connection was made, the applications exploded. Today, tensegrity principles are everywhere, in deployable structures, in robotics, in architecture. But here is the astonishing part. Johansson's work sat in archives for 40 years before anyone recognized its engineering and scientific potential. It wasn't until 1960 that Buckminster Fuller, a powerful figure, independently rediscovered the principle and named it tensegrity. Suddenly, the idea that had been just art had a name and became architecture. And the idea stayed in architecture due to Buckminster's claim to fame that was the geodesic dome, which you see there on the left of the slide. It was his student, Kenneth Snelson, who moved the idea into the center of art. By the way, Snelson had been a student of Buckminster Fuller, preferred the descriptive term floating compression, but the name tensegrity won. A couple of lessons here. Who gets credit for an idea when fame is involved, and the value of a name? In any case, here you have Snelson's Needle Tower, which is in Washington, D.C., something that seems to be floating in air. Today, origami and tensegrity principles are everywhere and coming together in aerospace, biophysics, smart materials, and much more. Origami engineering is now a field. Here you have a sampling of concepts from my colleague Claudio Paulino at Princeton University. The mathematics the physics, the structural principles, they were all there way before 1960. What was the barrier? Clock thinking had drawn rigid boundaries between domains. Johansson was an artist, therefore his work belonged into the art domain, and even there he was not widely recognized. Engineers didn't attend art exhibits looking for structural principles, and artists didn't frame their work in engineering terminology. The connection became visible only when someone stood at the intersection, when the same object was seen through multiple lenses simultaneously. This is the essence of nexus thinking. Which brings us to, can AI find all hidden connections? This matters enormously as we navigate our AI-saturated future. We might assume that machine learning will find all the hidden connections, that we have automated discovery itself. Well, in 1960, AI exists as we know it today. You feed it every engineering paper, every architectural drawing, every structural analysis prior to 1960, and you ask, how can we create lightweight, strong structures for space exploration? Would AI have directed to Akira Yoshikawa, origami's grandmaster, or to a Latvian with sculptures from 1920? Almost certainly not, because the question itself assumes engineering sources. The training data would be engineering literature. The domain boundaries are already built into the query. AI can explore what Stuart Kaufman calls the adjacent possible, the realm of combinations one step away from what we already know. But it cannot, by itself, ask, what if we treated this art installation as applied structural mechanics? That question requires someone who refused to accept that art and engineering were separate territories, someone practicing nexus thinking. 40 years from Johansson's to Fuller, 500 years from paper folding to space engineering. Not because the ideas were difficult, but because the questions that led to the connections did not exist yet. This is a sequence after the connection is made. Exploration, leap, development, or cloud, clock. Cloud thinking imagines new fields. What if paper folding is structural engineering, for example? Clock thinking develops them. Once origami engineering exists, we axiomatize, optimize, engineer. Both are essential. Cloud thinking breaks boundaries. Clock thinking builds disciplines. Discovery needs cloud thinking, but progress needs both. So here is the unsettling thought. What other origami and tensegrity moments are we living through right now? What older practices may contain principles that we haven't yet extracted? What connections we cannot quite grasp because our conceptual frameworks will not let us? What may we missing?